Hello buddy, today I'm going to do a little recap about chapter 5, which is about geometry. So, I'm going to start with the angles. So, there are different angles, like for example, right angles. Remember, always a square there for right angles that are always 90 degrees. And then we have acute angles here. They're always they're always less than 90 degrees. They're always less than 90 degrees. Okay? And then, after that, we have obtuse angles. Obtuse angles, which are always more than 90. I think I did that other way around. This is more than 90 degrees, of course. So it's the other way around. On the you can imagine it like this. This is like a crocodile. It wants to eat the bigger number. And when it's bigger than 90, then that means that it's eating the obtuse angle because it's bigger. Then it's also the acute angle that is smaller than 90. So it's the other way around. Okay, so now a hard question about angles. How do you get that angle? It is a fairly difficult question compared to the other questions about angles. Well, we know that this a straight line like this would be 180 degrees. Okay, we know that that's 180 degrees. So we're just going to remove that part entirely. Then we can measure the rest of this. Let's say it's like, we can use a protractor to calculate that this is like, let's say, 92 degrees. And that means that we have to do 180 plus 92 to get the answer 272 degrees. That's just an example. But remember, when they're more than 180, meaning that the circle goes like on the other side and not inside the angle, you can just do minus the 180 degrees and then do the rest that's below it or over it. And yeah, and that was a hard question for this one, for angles. Yeah, and I'm also going to talk about triangles and other forms. For example, we know that a triangle can hold 180 degrees. So that would mean that if this side would be the same on all sides, be 60 degrees, 60 degrees, and 60 degrees. But then we can also switch that up, making this like 70 degrees and making this 50 degrees. We could do that too. So just remember, it needs to have 180 degrees. And it's just the same with other forms, but like a square has 360. It can hold 360 degrees. And just on and on and on. Okay, so now to 5.2. Okay, so in 5.2, we're gonna learn about the sums of different shapes. For example, as I said, just like right now, the triangle here, it can hold 180 degrees. Okay, it can hold 180 degrees. And why is that? That's because the formula for this is n, which stands for the number of sides, number of sides, minus 2 times 180 is the total sum of how many degrees can fit in that shape. So for example, as I said, square, that would mean 4 sides minus 2 equals 2. 2 times 180 is equal to 360 degrees. Okay? So you get what I mean now. So for example, let's try a harder one now. For example, let's say something with 10 sides. Let's even say 12 sides. Okay? 12 minus 2 is equal to 10. 10 times 180 is equal to 1,800 degrees. So I think you understand what I mean now, okay? I think you understand what I mean now. And this one doesn't really have any hard questions, except I can maybe do this. Okay, I'm gonna draw something really quick right now, and you have to figure out the answer to it, okay? 75 degrees. Okay. 125 degrees. And then I want you to give me the answer for A and B. And let's just say that A and B are the same. So we can put them both as A for angle. So A are both the same. I'm gonna give you a little bit of time to think. If you need more time to think than like 5 seconds, then you can just pause the video. Okay, so now I'm gonna explain why the answer I'm gonna give you now is correct. Okay, so 120. Okay, so we know that this has 4 sides. 4 minus 2 is equal to 2. 2 times 180. 2 times 180 is equal to 360. And that means 360 minus 75 plus 125. Now we can do that really quickly. 125 plus 125 is equal to 200, meaning that should say 360 minus 200, which is equal to 160. And as I said before, there are 2 sides that we don't know, meaning that we have to do 160 divided by 2, which is equal to 80 degrees. So A is equal to 80 degrees. Okay, and now for chapter 5, 5.3. So 5.3 is basically just about how to get the circumference of different shapes, but we mostly learn about circles here. So that would mean that it's just a recap of one of my older videos, but I'm still gonna do it again, okay? So here we have a circle, and as you know, how do you get the circumference of a circle, also perimeter, but perimeter is for all forms. The circumference is basically pi times diameter. So let's say that the radius here is 5 centimeters. That means that 5 times 2 to get the diameter, because the diameter is the entire length here. That would mean 10 centimeters. And 3.14 times 10 is equal to 31.4 centimeters. And that is the circumference of this circle here. Okay? And because I've already done this before, you can just watch one of my older videos that I posted about how to get the area and circumference of a circle, so it's even more. And now for 5.4. So 5.4 is basically just about area. The last one is about circumference, now it's about area. So you know how to get area. It's basically just doing 2 sides times each other, but you can't do like this side and this side because you know they're the same length. So you have to do this side and I don't know, this side. Let's say that one's 2 centimeters, this one's 1 centimeter. 2 times 1 is equal to 2. That's how we get the area of a rectangle. It's fairly easy. We learned that a very long time ago. And for the triangle, it's just the same. It's base times height. Remember that. It's always base times height on these simple shapes, not on the circle. So it's base times height. This is the base. Let's say it's 2 centimeters. But remember, triangle is always divided by 2 because it's half of a square or a rectangle or anything like that. And let's say the height is like 3 centimeters. That means that we have to do 2 times 3 is equal to 6 divided by 2. Wait. Divided by 2. and 6 divided by 2 is equal to 3. So that means that the area of this triangle is 3. Okay, now for a little bit more of a difficult shape. Let's do a parallelogram. Okay, so parallelogram is basically a rectangle. It could be a rectangle. It could be a square. The only thing with a parallelogram means that it has 2 parallel sides. But for this time, we're gonna do a parallelogram that looks like this. Okay, our parallelogram is gonna look like this. And you probably noticed what I just did there. You probably did. I took away one part of this parallelogram and added one here. I added one here and took away one here. So what you can do is just take this and put that there. Take the length and the height of the length until here. So that would mean here, not there. So you could just take the length of this side instead. No, wait, not that much, like that. But it doesn't really make a difference which side you measure, because they're both the same size, because this is a parallelogram. Okay, this looks a little bit complex now, but I can explain it a little bit easier. So here, I have a rectangle. I add this and delete this. You can just take this and put it there. Then you have it there, see? And it's no longer there. It's here now. And then you can just take this side that we're going to say is like 3. And this side that we're going to say is 2. And 3 times 2 is equal to 6. So this is basically the area of this form. 6 whatever, so let's say centimeters squared. And that was for area. And now we're gonna go on to chapter 5, 6. Wait, let me see if it even exists. Yeah, chapter 5, 5.5, which is about scale. So, I'm pretty sure I made a video about scale. You can go and watch that one now for even more information about scale. Yeah, I did a video about scale. So, but I'm still gonna do some things about scale. Okay, so you know, on a map can't fit everything. Okay, this map here. This map. This is not the size of real life. Like, real life is not the size of a map, and a map is not the size of real life. Like, a map to the shop is not going to be the same distance from your home to the shop. That's just too big for a map, and too much waste of paper. So instead, mathematicians and like all humans use scale. So for example, from here to there is 2 centimeters on here. It's 2 centimeters. But in real life, this is just a model. But in real life, it is actually, let's say, 6 centimeters. Meaning that it's 2 to 6. And scales, we always have to simplify. So we divide both of these by 2 and turn that into 1 centimeter, and the model is equal to 3 centimeters, or any other measurement, because it doesn't really matter when it's in scale. It can be like 1 decimeter of this would equal to 3 decimeters in real life. But this is not 3 decimeters anymore, so it doesn't really matter what you use. But it's just smart to use centimeters when you know this is in centimeters. Okay, so this is real life. Real life is free. So remember, it's always model on the left side and real life on the right side. And I don't think this has any harder questions, except maybe instead of putting 1 centimeter in the model is 3 centimeters in real life. We could do it all the way around. 3 centimeters on a model. Why did I put centimeters? I'm just saying centimeters, but it doesn't always have to be centimeters. 3 units in the model is 1 unit in real life. So for example, you use that for smaller things, for example an ant or stuff like that. So now we're gonna go to chapter 5, BU. Okay, so I went on to the last question on BU, which is question 5126, and the number A is how big is the angle between the times, like these things here, this, at 1430. So I've done 1430. I have done 1430 here right now. It doesn't really matter. You can have 232. It doesn't really matter on these type of clocks. It matters on digital clocks, but not on these clocks. So how do you get this? Well, we know that a circle is 360 degrees. Okay, we all know that. 360 degrees. And there are 12 hours in the circle. So if we do 360 divided by 12, what do we get? We get 30 degrees. So now they have 30 degrees. We know that 1 hour, like from here to there, is equal to 30 degrees. But here it's 30 to 30, meaning that it's gone half of here to there, which is 15 degrees. 15 degrees to the 3. And then from the 3 is 30, 60, 90 degrees. So it's 15 plus 90, which is equal to 105 degrees. So there are 105 degrees between the two hands, the two hands of the clock. So, I hope you enjoyed this video. Please leave a like and subscribe if you haven't already, and goodbye.